This is Pluto, once known as the ninth planet from the Sun. At least, that's how it was taught in schools. However, in 2006, that classification changed, and Pluto was no longer considered a planet, with many expected to move on from it. That assumption proved wrong. Both Pluto and its supporters were underestimated. Fortunately, a dedicated group of scientists remained committed to studying it. In that same year, when Pluto lost its planetary status, NASA launched the probe New Horizons to study this distant object up close for the first time. The findings were unexpected. Our previous understanding of Pluto was incorrect. Scientific consensus had missed key details, as Pluto turned out to be far more complex than imagined. While it may not meet the definition of a planet, it remains one of the most dynamic and intriguing objects in the solar system. You might wonder why Pluto was reclassified from a ninth planet. While it may sound controversial, the reason lies in the evolving way scientists define objects in the solar system. This process has been ongoing for a long time. In the 1800s, when modern astronomy was developing, there were around 20 recognized planets because newly discovered moons or large asteroids were often labeled as planets. Eventually, this required clearer limits. As a result, stricter criteria were introduced to define what qualifies as a planet, and these standards have continued to evolve. In 1930, a self-taught astronomer and telescope builder named Clyde Tombaugh was assigned to search for a proposed Planet X. Scientists believed an unknown object might be affecting the orbits of Neptune and Uranus. After 10 months of observation, Tombaugh detected a faint object moving slowly beyond Neptune. He had set out to find a planet, and by the standard of that time, that is exactly what he discovered. Although definitions had become stricter since the 1800s, only two main criteria existed in the 1930s. First, the object had to orbit the Sun, which excluded moons since they orbit planets. Second, the object needed to be distinct in its region, which ruled out asteroids because many exist together in similar zones. Based on observations at the time, Pluto met both conditions. It appeared to be the only bright object in the outer solar system. However, that assumption later proved incorrect. A major shift occurred in 2006 when the definition of a planet was updated. According to the new criteria, a planet must have enough mass to clear its orbit of other objects of similar size. In simple terms, it must dominate its orbital region by attracting or removing surrounding debris. A planet must effectively control its space. Pluto does not meet this requirement. Instead of traveling alone, it exists within a large region filled with icy bodies known as the Kuiper Belt. This region contains leftover material from the formation of the solar system. Pluto is not even the largest object there. It is simply one of the most visible due to its high reflectivity. This brightness made it easier to detect from Earth, leading to the initial assumption that it was isolated. Pluto is actually one of the most reflective objects in the solar system. Only Venus and Jupiter have higher reflectivity, mainly due to their thick cloud layers. Because of this, Pluto can appear larger than it really is when viewed from a distance. Additionally, Pluto follows an unusual orbit. Its path around the Sun is highly elliptical, sometimes bringing it closer to the Sun than Neptune, nearly reaching the distance of Uranus. Its orbit is also tilted by about 17 degrees compared to the relatively flat plane followed by most other objects in the solar system. As a result, Pluto often moves above or below this plane. Its orbital period is also extremely long, taking about 248 years to complete one revolution around the Sun. For these reasons, Pluto does not qualify as a planet under current definitions, but it remains scientifically significant. Its unusual characteristics make it an important subject to study. This is why engineers at Johns Hopkins University developed the New Horizons spacecraft to explore in detail. Coincidentally, NASA launched this mission in the same year Pluto's classification changed. One of the biggest challenges of this mission was distance. Pluto is extremely far from Earth, and reaching it quickly required careful planning. The New Horizons probe, which weighed about 1,000 pounds, was placed on one of the most powerful rockets available at the time, the Atlas V, equipped with 5 additional solid boosters. This configuration produced roughly 2 million pounds of thrust, allowing the spacecraft to leave Earth at very high speed. Within just 9 hours, it had already passed the moon, traveling nearly 10 times faster than the Apollo missions. After 1 year in space, New Horizons approached Jupiter. NASA used this opportunity to test the spacecraft's imaging systems. The probe captured detailed images of Jupiter and its moons, including a notable image of a volcanic eruption on Io. However, the primary purpose of this flyby was to use Jupiter's strong gravity as a gravitational assist, increasing the spacecraft's speed and directing it toward Pluto more efficiently. This journey is still quite long. Even with the gravity assist, it takes another 8 years to move through the outer solar system. As New Horizons approaches Pluto in 2015, it begins capturing its first images. 2 bright points of light appear in the distance, gradually moving closer over time. These are Pluto and its largest moon, Charon. The relationship between them is unusual. Charon is about half the size of Pluto and orbits at a distance of just under 20,000 kilometers. For comparison, Earth's moon is nearly 400,000 kilometers away. This close pairing between 2 relatively large bodies creates a unique tidal locking effect. Only one side of Charon faces Pluto, similar to how our moon faces Earth. However, Pluto also keeps the same side facing Charon. This means that if you stood on one side of Pluto, you would always see Charon fixed in the same position, while on the opposite side, you would never see it at all. Because Charon is so large, it does not simply orbit Pluto. Instead, both bodies orbit a shared center of mass located between them, making it appear as though they revolve around a point in empty space. This led to speculation about more exotic explanations, but it is simply a result of gravitational interaction. Observing this orbital motion was only the beginning. As New Horizons moved closer, it captured the first detailed images of Pluto's surface. The results were unexpected. Rather than a uniform icy sphere, Pluto displays a wide range of colors, including deep red, light blue, white, yellow, and orange tones. One of the most recognizable features is a large, pale, heart-shaped region formed by low-lying plains of ice. Each side of this feature shows different characteristics. The section closest to the spacecraft appears smooth and flat. This area, known as Sputnik Planitia, is roughly the size of Texas. What stands out is the absence of impact craters, suggesting that the surface is actively changing. Any marks are quickly removed, indicating ongoing geological activity. Along the upper edge of this region, visible patterns appear as lines formed by glaciers moving from higher elevations into plains. This provides evidence that Pluto's surface materials behave differently from typical ice. At such extreme distances from the Sun, temperatures on Pluto drop to around minus 229 degrees Celsius. Under these conditions, water ice becomes too rigid to flow as glaciers. This suggests that much of Pluto's surface is composed of nitrogen ice instead. Nitrogen, which makes up most of Earth's atmosphere, behaves very differently at such low temperatures. On Pluto, it freezes solid and can move slowly across the surface. A closer view of Sputnik Planitia reveals polygon-shaped patterns formed by convection currents beneath the surface. Heat rising from Pluto's interior causes the nitrogen ice to shift. Instead of forming liquid due to the near-vacuum conditions, the material undergoes sublimation, where a solid turns directly into gas. This gas rises and forms a thin atmosphere around Pluto. Although the atmosphere is very light, it extends far into space due to Pluto's weak gravity. Surface pressure is estimated to be about 1 million times lower than that of Earth. These conditions can vary depending on Pluto's position in its orbit. When it moves closer to the Sun, sublimation increases and the atmosphere may become denser. In such periods, atmospheric pressure could reach up to a quarter of Earth's, exceeding that of Mars and possibly allowing liquid nitrogen to exist temporarily on the surface. Another striking feature is the deep red region extending from the left side of the heart-shaped area. This region is commonly called Cthulhu Macula, though its official name is Belton Regio. The reddish color is believed to come from complex organic molecules known as tholins. These form when solar radiation interacts with methane and carbon dioxide in Pluto's atmosphere. Over time, these molecules combine, darken, and settle onto the surface, creating a red layer that spreads across different regions. This distribution of material highlights the movement of ice and gas across Pluto. Beneath the surface, additional features add to its complexity. One notable example is the large ice volcano known as Wright Mons, which represents another important aspect of Pluto's active geology. The volcano stands about 5 kilometers tall and 150 kilometers wide, and it releases a slushy mixture of water and methane. This is not the only cryovolcano on Pluto, but it is the largest. Scientists are still uncertain how frequently these eruptions occur, though evidence suggests that volcanic activity remains relatively ongoing. Despite the large size of Wright Mons, only one visible impact crater has been identified on its surface. This indicates that it is not an ancient formation and is instead resurfaced from time to time, at least on a cosmic scale. These eruptions may happen every few million years. The source of this slushy material, however, raises further questions. Earlier assumptions describe Pluto as a frozen, inactive body, but current data does not support that view. Observations from New Horizons indicate that Pluto's core is still warm. This suggests the presence of a subsurface layer of liquid water beneath the icy crust. Similar internal structures are expected in icy moons, such as Europa and Titan. In those cases, internal heat is explained by gravitational forces exerted by their parent planets. For Pluto, however, the source of this heat is not clearly understood. In the early stages of the solar system, temperatures were extremely high, with constant collisions between gas, rock, and metal contributing to planetary formation. Over time, most objects cool down, and smaller bodies are generally expected to lose heat faster than larger ones. Pluto is relatively small and located in a very cold region, yet it still maintains internal warmth, which remains an open scientific question. Charon may provide part of the explanation for Pluto's unusual characteristics. Given their similar sizes, it is unlikely that Charon was simply captured by Pluto's gravity. A more widely accepted idea is that the two bodies collided in the distant past. Instead of merging or breaking apart completely, they became gravitationally bound and now orbit a shared center of mass. The energy from that collision, along with their ongoing gravitational interaction, may have contributed to Pluto's internal heat. An interesting observation is that Pluto's distinctive heart-shaped region lies on the side opposite Charon. This positioning is unlikely to be random. In addition, the same reddish material, composed of tholins, is also found on Charon. This may result from material ejected by volcanic activity on Pluto. Due to Pluto's weak gravity, some of this material can escape into space and later settle on Charon's surface, particularly near its North Pole. The images studied today may be the last detailed views of Pluto for a long time. Current priorities at NASA are focused on closer targets, such as Venus and Mars, along with missions to moons like Europa and Titan. At present, there are no confirmed plans for a follow-up mission similar to New Horizons. However, the journey of New Horizons is not over. Due to its high speed, its close encounter with Pluto lasted only a few days before it continued deeper into the Kuiper Belt. Pluto is only the most visible object in this region, not necessarily the largest or most unusual. The spacecraft continues to explore this distant area, where many unknown objects remain to be studied, suggesting that further discoveries are still ahead.